Did you know that this is the biggest object humans have ever sent into space? It may not look like it, but this is actually a 20 kilometers long piece of wire that's as tall as the Empire State Building, well, 45 of them. But what's he doing there? It must be the universe's longest string telephone. Hello? Hello. Prepare for invasion, Earth. Well, that's not good. To actually understand what it's for, we need to look at Faraday's law of induction. If I move this loop of wire through this magnetic field, a small current is produced. You can increase the power generated by using more wire and moving it faster. In fact, stick a propeller on the end, and now you have yourself a wind turbine. This concept made the big brains at NASA go, you know how like the Earth is basically a giant magnet? Yeah, bro, totally. What if we use like a super long wire, bro? Huh. So $400 million later, this is the plan they came up with. Earth has big magnetic field, so we send spaceship with big wire. But Earth magnetic field very weak, so we send even bigger wire. Then we move spaceship super fast to generate power. Then we rule the galaxy. The system was called the TSS-1, or Tethered Satellite System 1. It had a base satellite, a sub-satellite, and a 20 kilometers long conductive tether connecting them both, acting as the wire. Now you may have noticed something wrong here. In our original example, we used a loop of wire, because electricity needs a closed loop to flow. And this tether is not a loop. But electricity is really just the flow of electrons. And it turns out there's a layer of the Earth's atmosphere called the ionosphere, which has a bunch of free electrons just floating around. So using a fancy electron collector and emitter, NASA designed a system to create electron flow using the ionosphere, completing the loop. In 1992, TSS-1 was launched aboard Space Shuttle Atlantis. It successfully reached the ionosphere, and it was finally time to unfurl the 20 kilometers long tether. Houston, we have a problem. This screw isn't set going to cut it. Okay, swap him out then. Hey, we should test everything again to make sure it works, right? Nah, should be. Good? It was not good. That beefy screw caused the tether reel to jam up. But a whopping 260 meters, pretty much 1% of its maximum length. Moral of the story, always test and retest after making any design changes. Quite the expensive lesson to learn, but surely they'll get it next time, right? Right. Woo, we made it. Plus 216 meters this time, and the tether successfully deployed to its full length of 20 kilometers. Houston, we have a problem. It was so close. But when the tether reached 19.7 kilometers, a small defect in the insulation near the bottom led to a large arc that melted it. And that's how we ended up here, a giant space noodle floating in the sky. It was sighted all over the world, in Australia, in Hawaii, in the southern USA. And a few weeks later, it re-entered the atmosphere, cooking the space noodle once and for all. But the big question is, did the experiment work though? Well, NASA managed to collect some data, and the tether generated almost 3.5 kilowatts of electrical power, enough to run 3 toasters at once. Okay, that doesn't seem like much. But for context, most small satellites only need 1 toaster's worth of power. Despite this, the tethered satellite system missions were abandoned, and the results weren't set publicized. Well, apart from being roasted by the media, I guess it is kind of embarrassing to have your mistake plastered in the sky for the whole world to see. But I really hope they try again, because I imagine a night sky in the future where space noodles hang from every spaceship and satellite. Bring back space noodles, please. I haven't seen the sun in years. See you next time.